So Roger, this quantum phenomena that you're talking about and looking to describe is a potential way out, or a potential way to explain a way out of humans having non-algorithmic insights.
Yes, well, the argument is that whatever it is that happens, you see, it depends on, I mean, it's absurd, because it doesn't just depend on changing neurophysiology, it depends on changing physics. And that's, sometimes people get very confused. They say, oh, we're saying that quantum effects are happening in the brain. Oh, no way could that be true. We're saying much worse than that. We're saying it's not quantum mechanics, it's where quantum mechanics goes wrong.
Right.
Does quantum mechanics go wrong? Most people don't think that. Well, you see, it's the collapse of the wave function. It's one of these very curious things. You see, Schrödinger, he understood better than anybody, because he introduced this thing called, what people call Schrödinger's cat. And the argument is that you have this cat in the box, and you can put the cat into a state of being dead and alive at the same time. Now, Schrödinger was not saying, look, if you made this box and you put it like this, and you can make a cat which is dead and alive at the same time. He wasn't saying that. He was saying, this is an absurdity. A lot of other people say, no, maybe you could make a Schrödinger's cat and do it, blah, 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 blah. Schrödinger was trying to say, look, this is where Schrödinger talking, my equation goes wrong. He was never quite putting it as blatantly as that. But roughly speaking, he was saying his equation is not governing the way the world operates. It goes along as long as you keep it isolated, and whatever it is, you have to be careful because different people have different theories about this. Whatever it is, where this thing called the collapse of the wave function, that is, you follow Schrödinger equation, this is following the wave equation, Schrödinger equation tells you it does this, 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 and this. You can put that on a computer. Yeah, you can put that on a computer. And then it doesn't do it, it collapses. That's usually what you call making a measurement.
Before we run out of time, we've got a little bit of time left, but
yes.
One of the things that Yang and I, we agree on almost everything, but the one thing we completely disagree on is the future of AI. I'm a great skeptic, yes. and Yang is a fan.
I'm a fan. I wouldn't say I'm a fanatic, but I'm a fan.
Yeah. So, so in particular, sort of the role of artificial intelligence, or advanced computation, machine learning, whatever you want to call it, the role of that in enhancing human creativity. So in particular, automated, conjecture formation, or creative acts, or even, Yang, as you like to think about, automated proofs. And so, some of the evidence for that is, systems. We've got a slide now about AlphaGo, and then there's AlphaZero. Right. And I think somebody in the audience here is one of the developers of AlphaGo.
Sure.
What's your sense on the role of computation, machine learning to enhance our creativity?
Oh, that's a difficult one. You see, you might explore the implications of something using a computer, which is what people do all the time now. You may have some idea about what's going on, and then you test it by computation. And a lot of physics is like that now. Sure, that's fine. There's nothing wrong with that. The question is whether you're making the computer creative. Now, what does it mean to be creative? You can certainly make it do things you hadn't thought of before. Now, is that creative? Well, I don't know. It's not usefully creative. It might by chance, you see. Well, I mean, it does this protein folding thing now, which, of course, that people have found it's very good at doing protein folding. Maybe. I mean, I don't like to... See, creative is a word that's rather hard to pin down, I think. I prefer to use the word understanding. There, you see, I think it's much clearer, because you couldn't say AlphaGo understands anything. I say I have an idea about how to... This is a nice challenge. I'd like to do it sometime. To see whether... I don't know whether it would work, but you might be able to defeat AlphaGo and whatever it is, Alpha Plus, whatever these things are called. Be an interesting challenge. I won't talk about it now because I don't want too many people to think of it ahead of time. But it is a way that, sure, it beat the world champion, but that's in the normal way you play Go, which starts with an empty board. So the idea would be to modify the game a bit. You see, the thing about making a very good Go player, that it's very clear what the aim is. I mean, you can tell who wins. So you can make it play itself a zillion times, and without understanding a damn thing, it can play itself a zillion times. And it knows which one wins, when it wins, and so it's clear what wins means. Now, it'd be very different if you have something which is not clear what the objective is. If it's got a clear objective like that, then maybe, yes, you can make a computer do it better than a human being, which is what happens with Go. That's right. But does it understand what it's doing? I think one could make a case that it doesn't. But I'd like to that's a challenge which I had in mind using. Now, I had this thing with chess, which you could do that.
Right. But there's a growing community within the mathematics community who, sort of saying that, this analogy of mathematics being like chess, and this community thinks that we can, within the next few decades, AI, or the likes of AlphaZero, would start proving theorems and raising new conjectures in mathematics that are better and faster than us. So what do you think of?
It's possible. You see, I'm not arguing against that, really.
Okay.
I'm just saying it doesn't understand what it's doing.
Right. So even though it's produced a correct proof of a correct theorem.
Yeah, sure. Well, there's examples of this. I mean, the four-color problem. There's a proof. I used to waste a lot of time on trying to prove the four.
Right, I see.
The four-color problem is proved. I believe now there is no proof at the moment which doesn't at some stage use a computer.
Exactly.
Now, does that computer have the faintest idea what it's doing? No.
I see.
Do we know why that calculation gives you a proof of a four-color problem? No. And not unless you follow the argument. What is following the argument? You've got to understand it. You've got to know what it means. Now, it doesn't mean that you can't take advantage of having the computers. That's what people do, and that's what they're for. But the question here is maybe it would find some clever little thing that nobody's really thought of, and a proof of it, I suppose. I don't see that's impossible. It's a bit sort of. Well, there is a thing which. There's a little joke in one of my books. I don't know if anybody's seen it yet. I can tell you the joke, yes.
Please.
There's a picture, I think it's in Shadows of the Mind, yes. There's a picture which is illustrating this understanding point, where it's got a picture of all our ancestors doing all sorts of wonderful things. There's in the foreground, you see the mathematician who's trying to prove a theorem. And he's completely devoted to trying to prove this theorem. And there's a saber-toothed tiger just about to pounce on him and eat him up, you see. So what I'm trying to say is that's not selected for. What is selected for is these people who build a wonderful mammoth trap. And you see the poor mammoth getting rather disturbed. He's about to fall into the trap. And you can see people building shelters in the distance and growing crops and domesticating animals and using their understanding. And that's why the concept of understanding with this universal quality was selected for, and consciousness was something which was developed in human beings. Nothing purely for doing mathematics and seeing how to do theorems which can't be proved by simple axioms and things like that. Now, there are examples like this, and I give this in the book. I think I do in that book. I can't remember what's in the book now. But anyway, what I'm trying to say is that the quality of understanding is something which uses consciousness. And understanding is something which is very broad in its applicability, and it has a very, very essential role to play in mathematics. Now, the example I think the Goodstein example is in Shadows of the Mind. That's a very nice example. You can explain to people who don't know very much mathematics. And it's a thing you can't prove by ordinary induction, which is, you learn that in school, how to prove, you can prove something is true for all n. And the way of doing it is using mathematical induction. But the Goodstein theorem is being shown you can't prove that by mathematical induction. Yet we know it's true. Now, how do we know it's true? Well, we can't have done it by, maybe these ancestors of ours could have formulated the idea of mathematical induction. But they can't have thought, what's the use to evolution of thinking of transfinite induction? That's what Cantor did. That's what you need to prove the good sign. You need transfinite induction. Okay, you can understand. You don't have to be Cantor to understand it. You don't need the genius of Cantor. Maybe he was a fluke and somehow could think of this. No, you just follow the argument. And you say, I see, that works. Yes, it's true. Mm-hmm. Now, how do we have the ability to see that when the algorithms, if they were just algorithms, that we use to develop our abilities, well, in fact, were just algorithms. Mm-hmm. We have to have something beyond algorithms which enables us to understand things. Now, I'm not saying that won't be achieved by future technology. I'm glad that I won't be around when that future technology comes about. But sure, there might be some, as I say, a latter-day Frankenstein who can create a conscious being. Mm-hmm. Maybe it can happen. Uh-huh. But it's not just by computation. You have to take advantage, according to me anyway, take advantage of whatever is going on in this part of physics that we don't understand yet, which is the collapse of the wave function. And somehow nature has done it already by itself.
So I've read early on, as a teenager, your first book up there, Members of Mind, and then more recently, this year I read your second book, where you sort of Shadows.
Yes, that's right.
I find these books more relevant today than ever before. I mean, so many people are debating, and I've had so many of these debates, and we've had these debates about the sort of brave new world of what could happen. And I find it's one of these little miracles to see that argument, to know that we know truths which are non-algorithmic, right? Cannot be done on any sort of computing device.